Okay, so today's date, it is 4/28/22. And by the way, if you guys do want extra credit tomorrow, come on down. Find me at the track sometime around 3:30, and I'll push work. Okay, so we know if we let's let x equal -1, 0, 1, 2, 3. Oh, we let make -2. So if x is -2, and I plug it in, if I plug in -2 into here, I get 2 to the -2 power, and I get 0.25. So I have a point of 0. I'm sorry, I did not mean 0. I've got a point at -2. Yeah. Yeah, who didn't get one? How did I miss you? How did I miss you? Everybody get one? Giselle, did I just miss you only? Oh, that's why. If I plug in -1, right, 2 to the -1 power, I get 0.5, so I'll have a point at -1, 0.5. If I plug in 0, I'll get 1. If I plug in 1, I get 2. If I plug in 2, I'll get 4, and if I plug in 3, I'll get 8. I'm just doubling. That's all I'm doing. Doubling each time because the base is 2. If I were to graph these points, then I'm going to get about there. It's like our Skittles, right? Our Skeeters. 2, 1, and 2, 4, 5, 6, 7, 8. Right. It is exponential growth, and my base is base 2. Okay, I'll step back and let you get caught up. We've done this graph before, correct? Okay. Now its inverse is just going to be the opposites. So the inverse, let's see if I can put that in a different color. Let's see, what color do I have? Green. Green will work. So its inverse would be at 0.25, -2, 0.5, -1, 1, 0, 2, 1, 4, 2, and 8, 3. Okay, there's the inverse. Okay. Because we know when we do the inverse, we just switch the variables, right? So then it would look something like this. There's my inverse, okay? Don't let me go too fast. How am I doing? So the domain of my exponential is all real numbers. I mean, it will forever go this direction. It's forever getting bigger in the x. So the domain is definitely x equals all real numbers. The range is y is greater than 0. Cannot equal 0, so we'll have an asymptote there, which I'm going to draw in the asymptote. Yes.
Is that supposed to be -3? 8 -3?
Positive 3.
Oh, okay.
Yeah. So I get my asymptote right there, but always question what I do, Sophia. I'm okay with that, okay? Now, if I look at its inverse, the inverse is a logarithm. So the inverse, the equation is y equals log base 2 of x. That's the equation of the inverse, okay? Base 2, because it is base 2, right, of x. So that's my logarithm. Now, the domain of, I'm going to show it. I want you guys to see this. It's super easy. When you do inverses, you switch x and y's, right? Remember that? So that means the domain of one and the range of the other also switch. With me? So if the x's and y switch, so does the domain and range. So the domain of this one becomes the range of the green graph. Can you see that? All real numbers. And the range of the exponential becomes the domain of the inverse. So you can see for the y's, all real numbers, and for the x's, greater than 0. Okay, and you can see it from the graph as well. So domain and range switch. So the domain of its inverse is x is greater than 0. And the range is going to be simply all real numbers. Y is equal to all real numbers, okay? That's a logarithmic graph and an exponential graph. Okay, example 2. There's not much difference between these two graphs because E is approximately 2.7. So the graph between my 2 to the x, okay, I'm going to compare it. So these two graphs are going to be very similar. This is a 2 to the x, this is going to be a 2.7 to the x. It just grows a little bit faster. So let's make some points. Let's plug in -1, let's plug in -2, let's plug in -1, let's plug in 0, let's plug in 1, 2, and I'll plug in even 3. I'll plug 3 in over here, okay? Run around, but I'll put 3 in here, okay? And I'm just going to use my calculator to get those values. I'm going to put in for x, right? I have an E button on my calculator right there, E to the x. So I'm going to just use my E to the x button. E to the -2. It's about 0.13 or 0.13. If I do E to the -1, about 0.36. It's almost doubling, isn't it? In fact, really good question. It's not doubling, but it's multiplying by this number. Because that's my base, right? That's my base. That's my E is 2.71, blah, blah, blah. Okay, so then it is close to doubling, isn't it? If I go E to the 0, I get 1. E to the 1 is E, which is about 2.7. E to the 2, quit. Just so you're right, it's awfully close to doubling, but it's a little bit more than doubling, isn't it? 7.4. And then E to the 3rd, I'm just using my calculator to do the work, about 20, okay? So I can graph these in also. Okay, so then I'm going to take and go -2, about 0.13 right about there, -1, 0, 1, 1 and 2.7, 2 and 7.4, 1, 2, 3, 4, 5, 6, 7.4, maybe about there, and then 3 and 20 is off my graph. So it's very similar, isn't it? It's just a little steeper. Just a little steeper, okay? And its inverse then, its inverse is just going to be the opposite. So if I wanted the inverse of this would be y equals log base E of x. That's the inverse. That's my inverse. But I'm going to write as y equals ln of x. Same thing. Whenever I see log base E, we write ln. I can do that in my calculator, but what I'll do instead is just switch these points around. So the inverse would be a 0.13, -2, a 0.36, -1, a 1, 0, a 2.7, 1, a 7.4, 2, and then a 23, all right? And I'll do that in green. Am I going too fast? Okay, I'll slow down. That's the inverses, and I'll slow down. I'll wait for you, okay? I got my original points from my calculator. Just use my calculator to get those values. And then to do the inverse, I just switch the points. And I'll wait for you, okay? What's that?
So there's two with
Yes. Yes, great question. Okay, and I'm going to start trying to graph this one so you guys can see it. So I'd have it at, looks something like that. Very similar, isn't it? That's my inverse. It's a log graph. That's y equals ln of x. Okay, now wait for you to get number 3.
Do we need to hit the domain?
No. Did I ask for that one? It's going to be the exact same. Exact same. Domain and range will be the exact same from the first one to this one. The only difference.
What is negative?
Huh?
I was gonna say, what is negative x like?
I'm going to answer that. Good man. That's what we'll do right now. Okay, so, yeah, so I agree. Giselle, you noticed that it was almost doubling, because E is this number, so your base is 2.7, not 2. So the two graphs are very similar. Okay, so let's check this out. Juan, you asked a great question, okay? So, if I have a negative x, there's my x values. My x values become negative. Or my negative x values become positive. Let's just go like this. It's a reflection over the y-axis because your x's become negative or your negative x's become positive. And it's just reflection. Can you see it? It's reflection over the y-axis. So we don't need to use our calculator. We can just go straight to this. We know we can take this graph right here and we'll just flip it. Yeah, Luz?
I got that.
Yeah. So I know it's going to look like this. 1, 2, 3, 4, 5, 6, 7, 8. Worst case, if we get confused, we can always use Desmos also. But I know it's that because, Juan, you asked such a good question. Yeah, I mean, that makes sense, doesn't it? So if we're ever confused, we just go to Desmos, y equals, and we're going to go 2 to the power of a negative x, and there it is, right? Exactly what I thought it was going to be. Okay, asymptotes. We're going to have an asymptote here. Okay, all right. Now, it says over, but I don't really need you to do over because I want to go straight to our journal real quick. I want to get this done. So let's go check out our journal. I want you to go to page 146 first. Okay, page 146. And there they are, right? There's the graphs we just did. Any exponential graph always looks like this. Yeah, Juan?
Sorry, the last one, for number 2, how do you figure that E was 2.7?
Which one?
Number 2.
How did I get what?
How do you figure that E was equal to 2.7?
Oh, check it out. There's my E button right there in blue. E is,
I'll use that.
yeah.
Okay.
Isn't that awesome? Okay, now let's go back to the journal. So there it is. There's your exponential, okay? The bigger the base, the steeper the graph. I'll say it again. The bigger the base, the steeper the graph. And there's its inverse, the log graph, okay? Here's the negative. Here's the negative one. And then there's its inverse, the log graph. Okay, you guys see that? So it's in your journal. It shows the exponential and the log. It shows exponential decay and its logarithm, okay? Now, I want to real quickly, real briefly go back through these. So I'm on page 150. We're going to real quickly go through this, okay? Real quickly. All right? Real quickly. So I'm going to take my graph. It's inside parentheses. Remember the silly, stupid little dance I do? Anything inside the parentheses, it's a horizontal movement, so it takes it 3 right. You guys agree with that?
Left.
2 left. Everybody agree with that? We've done this before. It takes it up 5, down 1. Okay, we've done this before. This is just a real quick review. It's going to make it shrink by 2 because it's going to end up being twice as wide. It's going to make it be twice as tall because it's half as wide. 3 times as tall. 1/4 as tall. Okay, so it's the same stuff we've done before. Okay, same stuff. If I look at the other page, we know this. We know the same thing with logarithms. The negative x, we just did that. In fact, Juan said it's a reflection over the y-axis, right? Right? Ever agree with that? But this one's a reflection over the x-axis. We've done all this before. So now, what are we going to do on our homework? So let's go and do our homework. Page 152. So we grab your journals. There's 6 graphs. Let's do them together. Page 152. Let's do them together. Let's get our homework done, and then we have the rest of the time to do our balloons. Okay. Page 152. Okay. Now I don't need these to be perfect. I don't need them to be perfect. Okay. And I'll show you what I mean. Okay. So.
152, you said?
Page 152, we're going to do one. So I'm on page 152. And we're going to do 1 through 6 all, and then we're done. Let's do them together. So page 152, we're going to do 1 through 6 all, and we're going to do them together, okay?